Hello and welcome to the CCNA Security Chapter 2 lecture. This chapter focuses on how we secure our network devices. In particular, this chapter is going to discuss how we secure access to our router through the command line, through remote access, and through the use of multiple different ways of assigning administrative roles. First thing we're going to do is just talk about how do we secure this edge router, and what is an edge router? Here's three different examples of ways to secure our networks with an edge router. One would be connected to the internet. We have a single router which is connected to our internal, we'll call this our clean LAN, and our external, which will be the internet or dirty side of our network. And then we will allow security features, ACLs, etc., to block incoming connections, only allow outgoing connections, items of that nature. This is not the most secure, but it is a cheap way of doing perimeter security. A more defense in depth approach would be having a screening router on the outside that can be used for basic packet screening, a firewall such as an ASA, which we cover later in this particular course, and then our internal clean LAN. Now, I've actually seen network designs also where there was a router R1 on the outside that's a pre-screening router. There's a firewall that is a firewall between the outside and inside. Then on the inside right here there will be an additional R2, which is an internal screening router. Sometimes you see that. A lot of times on modern networks that would be one of your central core switches like a 6500, 7000, 7K, running in a routing fashion on the inside. In a DMZ approach, we have the same thing we have in our defense in depth approach, except we put a DMZ off of our firewall. The idea is any publicly accessible servers, web servers, email servers, any of Moodle servers, anything that you would be accessing from the internet you would place in the DMZ. This way you do not have to open up holes into your clean LAN. You put it into this gray LAN. Okay, so this DMZ where we do not expect each individual machine to be trusted by the inside. So these are our three methods we can use to create an edge that is secure. Now, a couple things we've got to talk about with securing edge routers. One is physical security. You need to realize that if I walk up and unplug your router and walk off with it, regardless of how much security you have, you've forgotten physical security. Likewise, if the power goes off and your router goes down, guess what? It doesn't matter how good your security policy is, or how good your ACLs are, or how well you've configured your router to survive an attack. You have no power, it's not going to work. So make sure that you keep in mind physical security for your devices, especially with some of the smaller routers that are in play today for remote offices. It's just as easy to unplug it and walk off with it as it is to try to break into it. And the end result is a denial of service attack, and also it's a huge loss for your company because of the amount of money it will cost to replace that router. We're also going to talk about router hardening, which is going to be features and items that we'll place on the router to help it survive denial of service attacks, help it survive attempts to break into its command line interface, or even to the web interface via SDM or CCP, which is the Cisco Configuration Professional. Then we'll talk about operating system security, and that really gets down into making sure you're running the version of the iOS that does not have any known vulnerabilities in it. And that just means staying on top of updates, ensuring that you're aware of what is going on in the security world so that you can put the correct operating system on your devices. So what do we want to do to secure this edge router? Well, one is we want to secure or restrict our device accessibility. Who can log in to our device? From the console, remotely via the V2I lines, via SSH. Hopefully you're not running Telnet because it is not secure. We're going to log everyone that logs into the device. Okay. We want a banner to present legal notification to warn users, both legitimate and illegitimate, of the consequences of accessing our device. And we also want to ensure the confidentiality of data, and we do that as far as from a management standpoint with ensuring that our connections are in fact encrypted. So here's a couple ways of accessing the router. We can, on this router here, this is a PSTN, there is actually an auxiliary port on the router which can be used for reverse telnet and connection via the PSTN and a modem. Alright, serial connection here. You can telnet to the V2I lines or SSH, preferably SSH because telnet is not secure. And then you can also connect locally via the console port. So the CON port requires the Cisco console cable. Now they're even putting out Cisco USB console cables that you can use to connect to the USB port or the USB console connection on Cisco routers. So local access, access to the console port. Remote access would be access to the VTY lines or access to the auxiliary lines. Although I will say that auxiliary lines, since you have to use a dial-in modem, can be fairly secure. Here's a picture showing what I described earlier in our designs for the edge of our network. Here's an external screening router, a firewall, and then an internal screening router. The only thing I would change here is I would put a DMZ off this firewall, so there would be a DMZ available to put your externally accessible servers. Here's a brute force attack. Okay, this is a tool that can be used. Could be Kane, could be Able, could be. There's all different kinds of tools that can attempt to break into your networks. Using weak and simple passwords are a very quick way of getting your network broken into. You know, Secret, Smith, Toyota. These are easily guessed by password guessing programs. What you want to use is a combination of alphanumeric characters for your password, uppercase, lowercase, and a special character. Be aware though, the Cisco iOS is case sensitive, and so you want to make sure that when you type in these passwords, you type them in correctly. You can lock yourself out if you're not careful, and the end result will be you'll have to make a password recovery on your device. Your password policy, will be based upon your security policy. So the length, the creation, and the type of password that you will use will be based upon your security policy. Here's a couple ways of configuring administrative access we've already used. Enable Secret Cisco, CSC5IO. This is protecting privilege mode access. Okay. The Enable Secret command ensures that this password will be placed into the running config encrypted. Line V204 password Cisco login. This creates a password for the VTY lines. Line aux password Cisco. This creates one for the auxiliary, and here is one for the console. Each of these are techniques that we've used in the past, so this is not anything that's new to you in terms of securing a router. This CCNA skills. Again, executive timeout, you'd want to set this so that if you walked away from a console, you would ensure that the console actually closed after a certain amount of time, so it's minutes and seconds. So you can do exec timeout 5:0, it's 5 minutes. You also can set a minimum character length for your passwords. So password min length, this lets you set a minimum length. They are stating it's recommended a 10 character limit. Depends on your network again. Remember, it's your security policy that sets these particular items for you. You also want to do the service password encryption. This, however, only encrypts the passwords in the running config with a level 7 encryption, which is very easy to break. There are multiple Cisco password crackers on the internet that you just dump in the Cisco 7 password and boom, out comes the password. So be aware of that. The Enable Secret does use MD5, which is much stronger and is much harder to break. So one of the things we mentioned is that you need to actually create the ability to monitor and log and allow each individual user to access your router or switch network device. In this case, we're going to create usernames and assign them a password. And so we can do service password encryption, username junior admin with a password to let me in. Username junior admin, see how it fails because that doesn't meet our minimum password length of 10 characters. But if you do junior admin Cisco 12345, by the way, not a good password. This is a lab environment, but be aware you would never want to use this in the real world. Username admin secret Cisco 54321, and then you do line con login local. What this will do, this login local, will force the console to prompt you for one of the users that are set up in the local database. Later in the course, we'll talk about connecting to an external database, okay, connecting to a radio server, connecting to a TACUS server, so that you can access the usernames and passwords that may be stored in Active Directory, so that you can track every single user on the network that you give access to. But this is a simple way of doing it that allows you to use the local database. Okay. Once you do service password encryption, you'll notice that they are being encrypted with, if you don't change it, a level 7 password. But if you do where you said user admin secret Cisco 54321, it will actually use the MD5 encryption, level 5 encryption. So if you want to use level 5 encryption for your particular users, you can do that. And in fact, I would strongly recommend you do that, so that you will have better encryption of the passwords for your usernames. Now, some of the things that hackers will try to do, they'll try to break in by using successive login attempts. There's some things you need to be careful of here. One is you do want to delay between successive login attempts. That way it will help prevent someone doing a brute force attack. The login shutdown, you do want to do that as long as you make sure that you have a quiet mode access control list that will allow you in the event that the setup blocks everyone from logging in. And I'll show you that in a second. And then we also want to generate system logs. We'll show you how to do that with the syslog. First off, let's enhance our virtual login. So let's create username admin secret Cisco 54321. We'll go under a V2I line, tell it to log in local, so we can use these local accounts. Then we're going to go login block for 15, attempts 5 within 60. So we're going to block for 15 minutes, okay? Excuse me, 15 seconds, if you have 5 attempts within 60 seconds. So in other words, this will help limit a hacker who is attempting to do a brute force attack with a program, okay? So I'm going to block for 15 seconds if there are 5 failed attempts within 60 seconds. Alright. Now, this particular access list here, here's the important thing. This IP access list standard permit admin, we mark permit on administrative host, and then we put in 2 hosts. Okay. This will permit 1010 and 1110. During the block time, okay, so it's going to block for 15 seconds. Even though everyone else will be blocked from access to the V2I line, because you do quiet mode access class, by the way, the only other use of access class I know of, login quiet mode access class permit admin. This says that even during the blocked period of 15 seconds, the hosts that are permitted in this permit admin ACL, named ACL, these 2 hosts will still be allowed to log in. Okay? Very important. If you don't put that in, okay, you will block yourself with this login block for 15 attempts 5 within 60. In other words, if you don't put in the permit admin access list, you can actually, during the quiet mode time, a hacker could create a program that will continually attempt to log into your router, and the end result is that they will denial of service you from accessing your router. Obviously, you don't want that, so make sure you put in this access list or an access list similar to it to allow your management host to be able to log in during the quiet mode. Okay. Then we can also do login on success log. So we will log the logins and the failures. So either one, and that will then get logged later when we show you how to set up a syslog server. Okay. And then delay of 10 will tell how long it will delay between login attempts. Okay. Now here it is. Login block for 120 seconds. That's 2 minutes. If there are 5 failed attempts, okay, within 60 seconds. Now, put this in first. Actually, I wouldn't put that in first. I'd create my access control list, but you do have to put it in. Yep, you got to put it in first, and then you do IP access list standard permit admin. Put this in, and do login quiet mode access class permit admin. This will allow you to then, okay, get in with those 2 hosts in case you have that problem. And this delay, this is an optional command, but it delays a block. Okay, basically it helps mitigate the dictionary attacks, so that there'll be a 3-second delay before the prompt comes back up. so you can actually set a delay to slow down attempts at getting into your router with a brute force or dictionary attack. Well, dictionary attack and brute force. Okay. Alright, here we're doing a log command. Here's show login. This shows the router's in normal mode, okay, which means it's not being blocking. Total login failures is 4. Okay. Quiet mode access list is this. Delay of 10 seconds is applied. If there's more than 5 failures in 60 seconds, you'll disable. Here we see an attempt and an attack. Okay. On the 6th attempt, the hacker is blocked. Okay, or anybody would be blocked unless they were in the quiet mode access list. You'll notice here it will remain in quiet mode for 105 seconds, but it is being filtered by permit admin, which is our access list that we configured to allow us to get in with our network management devices. And here we can show our login failures, total login failures, and it will tell you who tried to log in. Obviously, we see a bunch of usernames and a lot of different source addresses, multiple source addresses. You can ascertain that more than likely someone is trying to break into your router. Now, that is securing the V2I lines. Okay, partially securing them. Here's using the banner. We've all made banners. There's different types. Okay, you can do, if you want to use, here's some tokens you can use. Host name, I don't know if I ever really show my host name of the router. Domain, line description, all those. Okay, I would really not place any of that information in there. What you need on your banner is a legal disclaimer that has been set by your lawyers that will match the requirements of your particular company, country, jurisdiction, that says if you come in here and you are not a valid member of the IT staff of this corporation, you will be prosecuted, period. Again, I'm not a lawyer. Go to your lawyer for your company and have your banner created by your lawyer so that will meet the needs of your company. Now, here's something else that you want to do. Anytime you're connecting to the V2I lines on a router in out-of-band management or in-band management, which is over your network, you want to be using SSH. Here's a Wireshark capture, and you'll notice that in Telnet you can capture the password right here. I know the username is Bob, password is Cisco123. If I try the same exact capture of an SSH, I will not get anything because the conversation is encrypted. Okay, so SSH is what you want to use. Telnet is bad. Okay, period. It's bad. So how do we set up SSH? This is straight out of the CCNA, folks. Configure your IP domain name. I also configure my host name first, but configure your IP domain name. Generate your one-way secret keys using the crypto key generate RSA general keys modulus, and then set your modulus size. Okay, 1024 up 4028. Be aware the bigger the keys are, the more processing power it will take to create those keys. Create a local username. Okay, username Bob Secret Cisco. That way it's encrypted with MD5. Line V2I04, login local, and then this is the important thing, transport input SSH. This will only allow SSH connections to your V2I lines. You need to make sure that is turned on so that you will be able to access your router with SSH. Do not use Telnet anywhere in the real world. Okay, it's too easy to set up SSH. Make sure it's on. Use it. Okay. Likewise, you can also change the version of SSH. SSH2 is more secure than SSH1. SSH1 had some security issues. Here's an IP SSH timeout that if there's no activity within 60 seconds, you'll be dropped. And then authentication retries of 2 will let you set the number of authentication retries before being disconnected. So all of these are options you can set. Know how to set this up because you will need to know it. Show SSH. Alright. You also have built into each iOS, you have an SSH client. So you can actually do SSH-L, that's the name of who you're going to log in as, Bob 219.216.82.101. It will then prompt you for the password, and you can hit type password in, and your connection from the command line of R2 will be secure to the command line of R1. I'm going to do a show SSH. Okay, you'll see that you have a connection from username Bob. Now, you can also do it from a host. You can use Terraterm. You can do all those things. I use Putty. Okay, Putty is the easiest to use. The other thing that's available, you do have Putty. You have Putty, windowed Putty, which you can get. Okay, but everyone has their own. The beauty of Putty is it's free, so that's what I tend to use, especially in the classroom. Here's configuring SSH in SDM. By the way, folks, the examples in the curriculum show SDM, but if you can create or do anything in SDM, you can do it inside of the CCP. There's really no big difference. As you can see here, there's no key set. So you would go to the router, you'd go to configure, you would go to additional task, you would go to router access SSH. Okay, you generate your ISA keys. Of course, you can't do that unless your domain name is already set. Okay, so you have to go into the router properties and set that. Generate the keys. Then you would have to go into the V2I lines for router access, and you have to tell what input protocol it would allow, which would be SSH. Okay, there's your lines 0 to 4. Here's your timeout. Here's your input protocol. This is the transport input. You just set it here in these two checkboxes. You can put access class. This is exactly what we did in CCNA. This is putting an access control list on a V2I line to control access to that V2I line. And then you have some policies down here, AAA policies that we're not going to go over at this moment. We'll talk about later. Okay, now we also need ways to control access to certain privilege levels. Right now, you know two privilege levels, user mode and privilege mode. The enable secret password is used to move from user mode to privilege mode. User mode is a mode where you can look and do no configuration and have limited access to commands. Privilege mode, which is level 15, lets you do everything. What we need to be able to do, though, wouldn't it be nice if we could create multiple privileged modes so that a security operator's privileges would allow them to configure AAA, do some show commands, configure some firewall, IDS, and NetFlow, but the WAN engineer could do more or could do different things. So we really need to be able to do that. And to do that, we go in and we can set privilege levels from 0 to 15. Now 0 is rarely used, but it does include 5 commands: disable, enable, exit, help, and logout. Now, the default level when you log in to a router at user mode is level 1, which means you cannot make any changes or even view the running config file. Levels 2 through 15 are customizable using the techniques we are about to show you. And the level 15 is the basically root level. It's the ability to do everything. Change configurations, view configs, everything. So we're going to change. Okay, we're going to privilege mode level. We're going to create new privilege modes. So here's a great example. We're going to say that username, user, privilege 1, secret, Cisco. Okay. Now, this is a user account with normal level 1 access. Okay, so if they type enable, they will get and put in user with the password of Cisco, they will get level 1 access. Okay. Now we have another user. We create another privilege level, level 5, privilege exec level 5 ping. This moves the ping command to level 5. Okay. Then we make a password for level 5, enable secret level 5 Cisco 5. Username support privilege 5 secret Cisco 5. In other words, we create a username, we give them privilege level 5, so if you log in with this username, you're going to have privilege level 5. You could also just do level 5 by doing enable 5 and going in as enable 5. Privilege level exec 10 reload. This puts the reload command at level 10, and this is the password for level 10. This is a junior admin that's assigned to level 10. Then we have an admin here. Now here's one of the problems with configuring privilege levels. A higher level contains every command for the levels below it. So 15 has all the commands. 10 has both reload and ping. This doesn't give you the granular approach that we will see later when we're using views. Okay? So there are some limitations to privilege levels. So here's an example. You log in, username is user. When you log in, you'll do show privilege. Current privilege level is 1. That user cannot ping anymore because we moved the ping up to level 5. However, if I go in here and do enable 5, put in the enable 5 password, do a show privilege, you'll now see that I have the ping command available to me. I can't do reload though, because we moved reload up to level 10. All right. So these are the types of things that you can do with privilege levels. You can move commands to different levels and give out those passwords so that certain individuals will have access to certain commands. Here again is level 10. If I do enable 10, show privilege, I can ping. Because the ping command is at level 5, I'm at level 10. Okay. I can also reload. I try to reload, but I can't reload. Okay. Actually, I can reload. Let's back up and make sure that reload is in. Yep, level 10 is reload. But show running config is not part of level. It's not on level 10. Now level 15, I can do everything. Okay. I can do everything because I am basically the root. I am the top level. So you can see in this example that we have moved commands to different levels. Now I can either access it by doing enable and the level number, or logging in as a user who is in that particular level or has been given that level's access. Now here's some problems with it. No access to control specific interfaces, ports, logical interfaces, slots. Commands set to higher levels are not available for lower, but the other way, if it's at a lower level, the higher level automatically has access to it. That can cause some weird or different inheritance problems for you. And multiple keywords for privilege level also assigns all the commands associated with the first keyword. So show IP route, okay, would give you all IP commands. So if you just do show, you would get all show commands. So how do we overcome this? We overcome it with what Cisco calls role-based CLI access. With the role-based CLI access, we're going to create different roles using views. And we can assign commands to those views and then give users access to those views, and then they will only have access to the commands in those individual views. So let's look here. Here we have the root view. Now the root view is what is used to define views and super views. Okay? So you got to be in root view before you can do anything. Then you can create multiple views, and each one of those views can contain different commands. Now, here's one thing that's very important. None of these views inherit anything from one another. In other words, view 1 gives you show interfaces. View 4 gives you interface FA0. If you want both of these, you're going to have to create a super view that combines those two views. Okay? Super views contain views but not commands. So a view contains commands and super views contain views. Root view is just where you configure from. Okay? So here we can see that we place the view 4 into both super view 2 and 1, and each one of these are little self-contained view containers of commands. Right? So this is role-based CLI access. Now, it's not that hard to actually set up. First off, you do have to enable AAA with the AAA new model command. That's one thing that's the first step. Know that, because without that you cannot enable root, you can't go into root view. So enable AAA with AAA new model at global config, and then you'll type enable view, alright, and you'll go into the view name. Okay, you'll go into the view. Alright. Now, once you go into view, that's root view, just enable view. Once you're there, you can then create parser views. Now, parser views are the actual views. Okay, it creates a view and enters the view configuration name. So if I did parser view Bubba, then I would be in that view configuration mode, and I can add all the all the commands I want in that particular view. So I can put all the commands to include, exclude, interface, all the different things I want to go into that view. Here's an example. If I do a parser view, now by the way, I've already gone into enable view to go into root view. Then after that I go into parser view, show view, okay, and we created a view called show view. The password to get into it is Cisco. Okay. Commands are executive include show. So in other words, from the privileged exec mode, allow all show commands. Okay. In the verify view, here's another view. We've included ping with a password of Cisco 5. All right. And we have actually I did that twice. They said didn't set the view, so I got an error message. And here's a reboot view, which gives command exec include reload. We look in the running config, we'll see our 3 different parser views, our 3 different views. Okay, show view, verify view, and reboot view. Each one with their individual commands, each one with MD5 encryption, because we use the command secret and then the password. Okay. Now, we also then can take and create super views. Parser view, view name. So if I want to do parser view junior admins super view, that would create a super admin, a junior admin super view. All right. Now give it a password, secret. So here we go. Then view name. This adds the views, the parser views I created earlier, into the super view. So here's an example. Parser view user super view. Okay, typo right here. Ignore that. Secret is Cisco view show view. This puts the show view we created in the previous slides into the super view that is user. Here we have a support super view, which has show view and verify view in it. 2 views. In the running config, we can see the super view. Support super view has show view and verify view. Junior admin super view has show view, verify view, and reboot view. So these individual views created with the parser view command are added under the junior admin super view. So everyone who has the password for junior admin, alright, would be able to go in, or for this particular view would be able to go in. So if you did enable and typed the password or enable 5, okay, actually enable, you'll be able to get in if you put in the correct password. So enable view user, this lets you verify it. Okay. Here's verify support, enable view support. Here's verify the junior admin, enable view junior admin. It shows you the commands that are available. And if you want to verify all, show parser view, enable view, show parser view, and you'll be able to see all your views that are present and the ones that are in fact super views. So show parser view all shows you your super views and your other views. Again, go through enable view junior admin, that shows you everything under the junior admin view, and support and user. So with role-based CLI, we have much more granular control of what we give our particular users access to. Much better than just using command line access. Now, a couple quick things here on iOS image configuration files. There are 2 commands that you can use: secure boot image and secure boot config. What this will do is it will create a hidden encrypted version of the iOS image so that users cannot access it or accidentally delete it with secure boot image. No secure boot image will remove that, will unencrypt it. And secure boot config does the same thing. It creates an encrypted boot config and hides the boot config from the output of the show commands. If you do a show secure boot set, it will tell you the information about the secure boot set. Now, it is important that you realize, okay, for this to work, you have to have an image that supports it. Okay, so that is one item to be aware of. This may not work if you don't have a supported security image. Now, also here's another thing, folks, password recovery procedure. I'm not going to spend much time on this because you should know this. You connect via the console, you turn right off, turn on, do a control break. Once you do a control break, you change config register from 2102 to 2142, okay, and then you reboot. Once you reboot it, will bypass the startup config. When that happens, you can then type enable, you go into the command prompt, and then you can do a copy running config to startup config, and then reset the passwords. This, if you need to review this, you can Google password recovery procedures, but this is something you should already know from the CCNA. Here's one issue you can get into, however. There is a command, no service password recovery. If you execute this command, you can no longer issue control break, and you can no longer recover your password with password recovery procedures. Be very careful about this, because with this disabled, you will not be able to do password recovery. It is better just to make sure that your router's console port is secure and that no one can physically get to it and leave on your password recovery. This, however, will be dependent upon your organization's security policy. If it states that you cannot allow access to the console for recovery, then you have to set this particular item to meet that policy requirement. Alright, how about reporting? How about logs? Well, a lot of the questions you need to ask yourself is, what am I going to log? What is important to log? Should I log everything? A lot of this is going to depend again on your security policy. You know, how much data will you need in the event of a criminal investigation? How much can you actually track and look at? You know, if we're syslogging everything, can we realistically look at all that? Okay. Now, there's two ways we can do management. One is out of band, and this is when you design and have your own dedicated non-production traffic management LAN. You can have a VLAN. Excuse me. A VLAN is set for out-of-band management, and on that VLAN, all of your management information crosses there. No data other than that will go across it. In-band management is all of your information travels across your enterprise network. The thing about an out-of-band management is you will have to dedicate an individual port to be part of the out-of-band management network, but it is the more secure method of doing things, doing management. So out-of-band management is the highest level of security. Okay, in-band, really you got to use IPsec, SSH, or SSL. Anytime you're doing in-band management, make sure all information from your management stations to the routers or switches are encrypted. In fact, I would say that's true whether it's inbound or out-of-band. Just in-band or out-of-band. Make sure it's being encrypted between your management devices and the networking devices. Now, there are 7 levels of logging, security levels, or severity levels of messages on a Cisco router. They go from 0 to 7. 0 is an emergency. The system is unusable. Okay, the system stops basically. And then there are alerts. Immediate action is needed. 2 is a critical. 3 are error conditions. 4 are warnings. 5 is notification, significant but not, it's normal but it's significant. 6 is informational, and debugging is everything. When you set up syslogging, you're going to have to decide what trap level you want to use. The trap level will correspond to what level you want in the syslog to monitor. Typically, we don't monitor debugging. That's too much information, because if you do login trap 7, login level 7, that's going to actually log everything from 7 down. So all information that's on the router will be logged. And that can overwhelm your syslog server and really give you a lot of information you just don't simply need. Alright. Now, here's some examples. Okay. Log emergency is a panic condition. iOS could not load. Temperature too high on the router. That could obviously end up with the router being corrupted and or melting down. Crashing due to temperature. Unable to allocate memory, invalid memory size, crypto warning, crypto operation failed. Now debugging could just be a packet type invalid. Okay, and here's log message. Timestamp, which by the way, it's very important that you set the time correctly on your particular router. Okay. Otherwise, you go to prosecute someone, you say, Your Honor, here are the logs of the individuals breaking into our network. The lawyer for that individual looks at the logs and says, well, that was 7 p.m. Well, guess what? I have 27 witnesses at this bar that state that my client was at the bar with them from 7 to 12. So explain to me how my client is the one who broke into your network. There you go. He walks away. He or she walks away. So make sure your time is set correctly on your router so that your logs are stamped with the correct time. Here's the message name and severity. Here's level 5. Okay. And here's the actual text of the message. This is what will show up in your syslog server. So here's our syslog server. Here's our client. We're going to set it up. So syslog client sends information, log messages to the syslog server. So pretty simple there. Here it is, login host, and then we put in either the host name for using DNS resolution on our router or the IP address of the remote syslog server. So in our case here, it will be on this client, login host 10232. Alright. We can also set our trap level, login trap level, and this is from 0 to 7. Okay. Most of the time 4. Okay, we'll use 4 because remember, we go back here and look, 4 was warnings. Okay. This again is based upon your security policy. Some may say 3 or lower, but it just depends on your environment. So set the interface. This is the source interface. So this is where it will come from the client. So login source, enable login, logging on, had to turn it on, and here's our sample config. So we have syslog client, login host 10226. They moved it from our picture into the DMZ, which is out here. Login trap informational, which gives you information. Login source loopback 0, which gives it an interface that's always up, okay, and would be configured with an IP address, and turns logging on. With this, everything informational or less, okay, in other words, anything informational or more severe, would be logged to the syslog server 10226. Now, on this syslog server, you've got to have a syslog server running. So there has to be software loaded on this box. It has to be accessible to the syslog client. You know, if you can't ping your syslog server, you more than likely cannot send syslog to it. So be aware of that. You have to have connectivity for that to work. You can do the same exact thing in the SDM or the CCP, okay, by going to the config, router properties logging, set the login level, set the host name that you're going to log to, and the debugging level, so you can set your level here for the login buffer. Okay. Now here's syslog server. You can click monitor and you actually see what you're sending. This shows you the logging, okay, the syslog logs that are being sent. Okay, shows you all the information that's being sent. And there's also a thing called SNMP. We're going to spend just a little bit of time on it. I'm going to tell you now, don't use anything but SNMP version 3, even though they don't talk about it here, because SNMP version 3 allows you to do encryption between the agents and the management nodes, okay, the management stations, so the managed nodes and the management stations. So there's a couple ways you can do this. SNMP agents loaded on each individual node, and you can set up traps, and when a particular level is reached, let's say utilization of 50% on the CPU, it sends a message to the network management station. You also can, with the NMS, do GET, so you can poll your managed nodes, poll the agent and say, hey, there's a MIB, it's called a management information base. So part of that MIB may be, tell me your CPU utilization, and that would be a GET, and it would get CPU utilization. All these devices would then send that back to the network management station. There are also ways to set things with the MIB, so I could even set particular items like IP addresses, login modes, those types of things with SNMP. And I would say use SNMP 2 or 3. SNMP 3 would be the one that would be more secure. Make sure you change those read-write community strings from public-private, because those are dangerous. In fact, a lot of times you have to be really careful with SNMP. It's better that you run SNMP 3 so that you can encrypt the messages between the managed nodes and the management stations. Also allows for authentication of the network management stations to the network managed nodes. Okay. Here we can set it in basically SNMP and CCP. You can do no auth, which doesn't make you have to do authentication. Authentication using HMAC, the MD5, or SHA, or you can do PRIV, which is a packet. It has to use HMAC MD5, HMAC SHA, triple DES, or AES. But all of these are encryption methods for SNMP version 3, so that between the network management station and the managed node you can have encryption. Okay. And here's where we're setting up our trap receiver. That would be the network management the network management server from the network management managed node. And here, setting our clock. Okay, that's one way we can do it, clock set. Or you can also do it in here, change the settings on date, time, and CCP. Or we can use NTP, and we set a network time protocol master. Okay, and we do NTP, and then tell it what server to use and what version, source name. Here's a sample config. If this was your being synchronized, you could do NTP server 10.10.10.1, which is here. Show clock, show NTP status, and this would be NTP master 1. Okay. There is a new version of NTP, a newer version that allows you to do authentication, and here it is. So you want to do NTP authenticate, NTP authentication key, key number, MD5, key value. And this is so that you can do secure. So you go to R1, NTP authentication, NTP authentication key 1, MD5, Cisco 123. I would obviously use a better password than this. NTP trusted key 1. Okay. And then on the opposite side you would have to do the exact same config so that you can see it's authenticated. Okay. So we want authentication between our NTP peers. Otherwise someone could put in erroneous time information. You can set this up inside of CCP also. Same thing. Okay. Now, security audits. A couple things we can do here. Cisco has some built-in items. It has several security audits that allow us to look at unused services, unneeded services. One of the things we can do is the security audit wizard. When you do that inside of CCP, perform security audit, it will provide a list of all the vulnerabilities and then ask you if you want to change them. Okay, and it allows you to choose which ones to change. Alright. The big thing about security audit being the audit wizard versus auto secure. The auto secure does the same thing, but if, depending on the mode selected, the auto secure can actually go ahead and go in and complete the changes without any administrator interaction. Okay, it can be dangerous because one thing you need to be aware of is one of the items it will try to turn off is CDP. Well, CDP is needed for certain devices like Cisco phones, and if you turn that off in a global setting because of Cisco Auto Secure making automatic changes, your phones may suddenly quit working in your environment. You're more secure, but your accessibility went way down. Okay, so Security Audit Wizard will go through, do a security audit, and then make suggestions for changes, and then allow you to say yes or no. Cisco Auto Secure basically works the same way, but it has the ability to do automatic changes for you if you set it up that way when you start it. And it's a command line. It's a command line tool. So Security Audit Wizard is the SDM version, and Cisco Auto Secure is the command line version. And then inside the SDM or CCP, there's the one-step lockdown. If you use it, it will do an audit and it will automatically make the changes to your device. Okay. So the Auto Wizard and Lockdown are based on the Auto Secure feature, but the difference is Auto Secure will not automatically make the changes for you, the Auto Wizard, and the Lockdown will make the changes immediately for you. Auto Secure gives you the option of how you wish to do it, whether it will automatically do it or not. So here's Security Audit Wizard. Okay, so we go in, we click on Security Audit. You tell it, which interfaces are inside, which ones are outside, so which ones are clean, which ones are dirty. Here are the vulnerabilities that have been, have been found. And then, if you want to fix the problems, you can click all these, click Fix It, and it will turn off pad service. It'll turn off boot P. It'll turn off CDP. Source routing will be turned off. All of these items will be turned off, and then you will get a summary of what has been fixed. So with the Security Audit Wizard, you're given the option of picking which items you wish to place into, to be changed, to be fixed automatically. With Auto Secure, again, depending on which way you turn it, which way you run it from the command line, it does the same thing as the Audit Wizard. Okay, but it can either automatically make the changes or prompt you to make the changes, one of the two. Last but not least, when you go in, here's the Auto Secure with its different how to do it. Auto Secure NTP, Auto Secure SSH. So there's an interact and a no interact. With no interact, it will go through and automatically make all the changes, okay, from the command line. In interact, okay, you have to tell it what you wish for it to do. In auto secure, okay, here it is again, identifying the edge. So you have to identify inside, outside, identify, securing the management plane, securing the banner, passwords, interfaces, and the forwarding plane. All those items are part of auto secure. The one-step lockdown wizard, when you click on it, it's going to disable all of these services. Finger, PAD, TCP, UDP small servers, IP source route, CDP, okay? Password encryption is going to be enabled. TCP keep alives for inbound and outbound telnet, okay? Minimum password length set to 6. Authenticate. All of these items, they're done automatically for you. So you need to be aware of that taking place when you use the auto secure, or the one-step lockdown tool in SDM. So auto secure command line can run in interactive or non-interactive mode. In interactive mode, it prompts you for changes. In non-interactive, it will automatically make the changes for you. Okay. The one-step lockdown tool will automatically make all the changes for you. Okay. The auto audit wizard inside of SDM, which is not shown on these two pages, but the audit wizard will find all the items that don't match the preferred security settings on the router, and will then prompt you and ask you if you want to change those. So 3 tools that perform many similar functions. So folks, that is chapter 2 of CCNA security. I hope you've enjoyed it. If you have any questions, please let me know.